Hello everyone, this is Srividya, Assistant Professor in the Department of CSIT. Today I am going to discuss quicksort in C. As in the previous session, we have seen what is bubble sort, what is insertion sort. So we have seen the two sorting techniques. In this session, I am going to discuss quicksort in C. So this is the overview. We will see what is the definition, working principle, time complexity and advantages and disadvantages with quicksort. So what is a quicksort? Quicksort is a highly efficient comparison-based sorting algorithm that uses a divide and conquer approach. So what you will do here, you will take a list of elements and you will divide or partition your elements. Based on that, you will perform your sorting techniques. It partitions the array into two subarrays around a pivot element and recursively sorts the subarrays. It partitions the array into two subarrays around a pivot element and recursively sorts the subarrays. Suppose you can consider any element as the pivot element. Suppose if you take the array like this. So consider this is my array. If I take the element 5, which is at the index position as the pivot element. So the elements, the first thing is you have to place the pivot element here. The elements that are left to the pivot are smaller than the pivot and the elements that are right to the pivot are the greater elements. So like that it should be. So first thing is you have to place your pivot element. Choose a pivot element from the array. Rearrange the elements such that those smaller than the pivot come before it and those larger come after it. Recursively apply the same procedure to the left and right subarrays. Time complexity. Best and average cases of the quicksort is order of n log n and worst case is order of n square. The space complexity is order of log n for recursion stack. We'll see what are the advantages and disadvantages. Before going into the quicksort algorithm, let's see what is the algorithm for the quicksort technique. So, to place the pivot element in the order, so algorithm for the quicksort is first consider the first element as the pivot element. Consider the first element as the pivot element. Next, initialize I to low and j to high. Next, third step, repeat the following steps until, so you have to keep on incrementing I and decrement j. So repeat the following steps until I less than j. So repeat the following steps until I less than j. Keep on incrementing I. The next step will be keep on incrementing I. So until where? Keep on increment I while a of I less than or equal to pivot. A of I less than or equal to pivot. And then, so what you will do after that? You will swap a of I and a of j. So in this condition, if I less than j, swap a of I, comma a of j. So if I less than j, you have to swap a of I and a of j. What happens if I greater than j? If I greater than j, then swap j with the pivot. So this is your algorithm. So first step, consider the first element as the pivot element, and next two steps here. You will take two values I and j. First you will initialize I2 low and j2 high until repeat the following steps if I less than j. So you have to swap the value j and I get swapped. So let's see with an example. So now we will start comparing with 50. So it is 50 less than or equal to 50, condition true. 30 less than or equal to 50, condition true. 10 less than or equal to 50, condition true. 40 less than or equal to 50, condition true. 80 less than 8 less than or equal to 50, condition true. 90 less than or equal to 50, condition false. So at I is equals to 6. 70 greater than 50, true. 90 greater than 50, false. At j is equals to 90 greater than 50, condition true. 20 greater than 50, condition false. At j is equals to 5. So now you will check I less than j. 6 less than 5, condition 6 less than 5, condition true. 6 less than 5, condition false. So 6 is not less than 5, condition false. So you will swap j with the pivot. Where is j here? J is here. So your pivot value is this one. So your pivot value is this one, j is there. Now you will swap your j with the pivot. 20, 30, 10, 40, 8, 50, 90 and 70. So this is your pivot value. The elements that are left to the pivot, it's left as sub array, and the elements that are right to the pivot are right sub array. It's right sub array. So now we have placed the pivot correctly. So now what you will do? You will again take the left sub array and you will again do the process, the same process whatever we have finished till here, and again you will do with the left sub array. So this is quick sort. So after that your sorted array will be 10, 20, 30, 40, 50, 70, 70 and 90. This is your sorted array. So let's see with one more example. 33, 10, 55, 7, 2, 44 and 60. This is your array. 33, 10, 55, 7, 2, 44 and 60. So you will start comparing from the first element. 33 less than or equals to 33, condition true. 10 less than or equals to 33, condition true. 55 less than or equal to 33, condition false. At I is equals to 2. So what we will do? You will initialize I2 low and J2 high, the highest index position. Okay. So at I is equals to 2, you got failed. Next 60 greater than, so now j will be decrementing. 60 greater than 33, condition true. 44 greater than 33, condition true. 2 greater than 33, condition false. At j is equals to 4. 2 less than 4, I less than j. I index position is 2, j index position is 4. 2 less than 4, condition true. So now what you will do? The condition was satisfied. It is 2 less than 4. So swap these two values. Okay. So if you swap these two values, the values will be like this. So next, I is at this position and J is at here. So again we will start the process from where we left. So where we got the value of I is at the second place and J is at the fourth place. So it's 2 less than or equals to 33, condition true. 7 less than or equals to 33, condition true. 55 less than or equals to 33, it's not satisfied at I is equals to 4. Now J. 55 greater than 33 to 7 greater than 33 false. So at J is equals to 3. I less than J. 4 less than 3. Condition false. So if 4 less than 3, condition false, what happens? You have to swap the value of the J with the pivot. Where is your J now? Here. Your J is here. So you will swap J with the pivot. So after swapping, the array is 7, 10, 2, 33, 55, 44 and 60. 7, 10 to 33, 45 like this. This is 44. This is your array and this is your pivot value. So this is your left sub array and this is your right sub array. So again you will start comparing the process with the left sub array. Left sub array is 7, 10 and 2. 0, 1 and 2. The index positions 7 less than or equals to 7 true, 10 less than or equals to 7 false, 2 less than, so obviously it is false. No, so now you will stop here because this is I and this is J. So at I is equals to 1. Next, 2 greater than 7 false. At J is equals to 2. So swap I and J. After swapping, what you will do here? So it is 7, 7, 2 and 10. So again you will take this one as your pivot value. 7 less than or equals to 7, condition true. 2 less than or equals to 7, condition true. 10 less than or equals to 7, condition false. At I is equals to 2, it got failed. Next, 10 greater than 7 true, true greater than 7 false. At J is equals to 1. So I less than J. 2 less than 1, condition false. So swap J with the pivot. So after that your array is 2, 7 and 10. So the left array is sorted. This is your left array. It is sorted. So next what you will do? Only the 2 elements that are already, only we have 3 elements again, same. 55, 44, 60. The same rule you will apply for the right sub array again. After sorting the left sub array, you got 2, 7 and 10. So now if you take again the right sub array, the elements at the right sub array are 55, 44 and 60. So what is your right sub array? It is 55, 44 and 60. So it's 0, 1 and 2. So again we will consider. Now this will be your pivot element. See, whenever you are taking the complete array, we are considering the first element as the pivot element. In the left sub array, I have considered 7 as the pivot element. Okay. Now here if you take the right sub array, here I am taking the 55, the first element again in the right sub array is 55. That I will consider as the pivot element. 55 less than or equals to 55, condition true. 44 less than or equals to 55, condition true. 60 less than or equals to 55, condition false. At I is equals to 2. 60 greater than 55. Now J is decrementing. 6. You are moving towards this direction. 60 greater than 55 true. 44 greater than 55 false. At J is equals to 1. 2 less than 1. So you are checking I less than J. 2 less than 1, condition false. So 2 less than 1, condition false means swap J with the pivot. So if you swap J with the pivot, what you will get? So your j is at 1 position and your pivot is at the 0th position. So you are swapping those two. 44, 55, 60. 0, 1 and 2. So the right sub array is already again it is sorted. So now if you want to write the complete sorted array, the complete sorted array is 2, 7, 10, 33, 44, 55 and 60. This is your complete sorted array. So this is what the process. So the quicksort follows the divide and conquer method. So you will divide the list into sublist, and again in the left partition again you will consider the pivot element and you will do the process. Again you will do the same with the right sub array. So after the process, this is your sorted array, and we'll see with the program. So hash include stdio.h void quicksort of. So here we have considered, we will take using functions because we need to follow the recursion technique, because every time if the list is not sorted, again you will call the elements and again you will do the sorting process until it gets sorted. So in the function definition, this is your function definition part. What we have taken, void quicksort of int array of int left comma int right. Those are the parameters which we have passed there. Obviously what you can say, that is the subscript of the array. It is 1D array. Obviously we are doing it on 1D array. So you will pass, how to pass an array as an argument, you will just pass one subscript as the parameter. Int left comma int right. Int I is equals to left, it is initialized I to left and j to right. Next int temp. Int pivot is equals to array of, how to calculate the pivot element, left plus right by 2. The partition. Next, while I less than or equal to j, what we have done, when I less than or equal to j, what we have done, so you will consider whether I less than or the pivot or j greater than or equal to the pivot. So if I is less than the pivot, you will increment the value of I plus plus, and if the value is greater than the pivot, the j value will be decrementing. So this is the condition. If I less than or equal to j, the swapping. If I less than j, what we have done, we have swapped the values of I and j. So for that we need a temporary variable t, and we will assign the value array of I. Array of I is equals to array of j, j is equals to temp. Next, from where we have started, again from that location you will keep on incrementing I plus plus and j minus minus. So if left less than j, quicksort of array comma left comma j. These are the parameters. Next, if I less than right, quicksort of array comma I comma right. So next, this is your main section. In the main section, what we will write, how many number of elements you want to enter, that you will take it in runtime, scanf %ld comma address of n, and you will give input like for I equal to 0, I less than n, I plus plus, scanf %ld comma address of array of I. Next, quicksort of array comma 0 comma n minus 1. If you look this clearly, it is a function call. Quicksort of array, the name of the array we have taken as ARR, the name of the array. 0 and n minus 1. 0 is the index position starting and n minus 1 is the last element. So array already started with 0 to, it will start with from the index position 0 to n minus 1, and printf %ld comma array of 5. So here enter the number of elements. 5 we have taken the number of elements, and those 5 elements are 10, 3, 2, 6 and 5. After sorted, the array is 2, 3, 5, 6 and 10. So this is your answer. So this, whatever the process we have followed while doing the example, the same we have written in the program. If the value is less than j, what we have done? We have swapped the values of I and j. If not, what you will do? Again you will take the recursion value and you will swap the elements. So this is the quicksort technique. In the next session, we will see files in C.